Students, today's topic is equality of matrices. So, today's topic is equality of matrices. Matrices. So, now I'm going to define two matrices. A equal to Aij and B equal to Vij are said to be equal if they have the same order. That is, matrix A is suppose the order m by n, so that implies matrix B positively of the order m by n. If matrix A is of the order m by n, say then positively matrix B of the order m by n. That means they have the same order. Second one is each element of matrix A is equal to corresponding element of matrix B. That is, Aij equal to Bij for all I and j. Right? Again, I am repeating the same things. Two matrix A and B are said to be equal. दो मैट्रिक्स को हम इक्वल मैट्रिक्स कब कहेंगे? जब दोनों का ऑर्डर सेम होगा. And each element of the first matrix is equal to corresponding element of the second matrix. For an example, here A is a matrix of the order 2 by 3, suppose x, y, z, 7, 9, 10 of the order 2 by 3. And B is the matrix of the order -2, -3, 0, P, Q, R. Also the order what? 2 by 3. I am saying they are the equality matrix. They are the what? Equality matrix. So when they are equal matrix, they have the same order. So look at here. Here order of matrix A is equal to 2 by 3 and also order of matrix B is 2 by 3. Then what the second is saying? Each element of matrix A. Each element of the matrix A is equal to corresponding element of matrix B. That implies Aij equal to Bij. That means if you start from A11, so positively it is equal to A11 element of the second matrix. Right? Again, I am repeating same things. If A11 element of the first matrix, if these two matrices are equal, they are the equal matrix because they have the same order here, and the condition is they have the same order, and each element of the first matrix is equal to the corresponding element of the second matrix. That implies Aij equal to Bij. That implies what? A11 means if A11 of the first A11 element of the first matrix is equal to A11 of the element of the second matrix. That implies what you say? So x is equal to -2, y is equal to -3, z is equal to 0. Then 7 is equal to p is equal to 7, q is equal to 9, and r is equal to what? 10. So what to conclude here? If two matrices are equal, so that implies they have the same order, and each element of the first matrix is equal to corresponding element of the second matrix. So let us discuss one of the question from exercise 3.1. So here it is given question number 7. Question number 7, exercise 3.1. Exercise 3.1, question number 7. Here it is saying that find the values of A, B, C and D from the equation. So here these are the two matrices given here. A minus, the elements are A minus B, 2A plus C, 2A minus B, 3C plus D. Right, students? Is equal to minus 1, 5, then 0, 13. So here they are the equality matrix. So they have the order. What are their order? 2 by 2 and 2 by 2. What the definition tells that? They have the same order. So they are the same order. So if they are equal, so they are equal matrices given in this question number 7. So their corresponding elements are equal. That implies first element of the first matrix is equal to each element of the first matrix is equal to corresponding element of the second matrix. So that implies a11 of element of the first one is equal to a11 element of the second one, and so on. So what you get? So that implies a minus b is equal to minus 1, 2a plus c is equal to 5, 2a minus b is equal to 0, and 3c plus d is equal to what? 13. So these are the equations 1, equation 2, equation 3 and equation 4. So I am solving it. A minus b is equal to 1, equation 1. 2a minus b is equal to what here? 0. By solving, suppose I am solving elimination method. Right? So this is 1. They are the same sign here. So what I do? I will just subtract it. So minus, this is plus, this is minus. They are cancelled out. So it is minus a is equal to 1. A is equal to what here? Minus 1. A is equal to what? Minus 1. Then putting a is equal to minus 1 in 1. So minus 1 minus b is equal to 1. Minus b is equal to what? 1 plus 1. B is equal to minus 2. So again come to C. 2a plus c is equal to 5. Then putting a is equal to minus 1 in equation 2. What you get? 2 into minus 1 plus c equal to 5. Minus 2 plus c equal to 5. So c equal to 5 plus 2. C is equal to 7 here. Then C we get now C. Then use putting this value of C in 4. Putting C is equal to 7 in 4 equation. So 3 into 7 plus D is equal to 13. So D is equal to 13 minus 21. So D is equal to how much? 8 minus 8. So these are the respective values of A, B, C and D students. Right? So this is all about equality of the two matrices. Sometimes it comes for 2 marks, also for 1 marks. Okay. Then just a minute, students. Yes, students. Now from 3.1 exercise, I am solving a question. If a matrix has 24 elements, question number 2. A matrix has 24 elements. What are the possible orders in it can have? What if it has 13 elements? Here, the matrix has how many elements? 24 elements. Students, I am discussing exercise 3.1. Okay. So here the matrix has 24 elements. So you know that the order of the matrix tells how many elements the matrix contains. So what we will do now? Here the matrix has 24 elements, and the question is asking that find the possible orders here. So, in place of 24, what you write? 1 multiply 24. Also 24 multiply 1. Then 2 multiply 24. 24 multiply 2. Then 4 multiply 6. 6 multiply 4. Then 3 multiply 8. Also 8 multiply 3. So students, these are the possible orders. 1 by 24, 24 by 1, 2 by 12, 12 by 2, 4 by 6, 6 by 4, 3 by 8, and 8 by 4. So these are the possible orders if a matrix consisting of 24 elements. So your question is, sir, how in previous classes, previous lecture, I told you that the order of the matrix tells that how many number of elements contained by the matrix. So here the total number of elements are given. So you from these elements, from these 24 elements, we make possible orders here. Then again it is saying that if the matrix contains, if the matrix contains 30 elements, a matrix contains 13 elements. So students, what are the possible orders here? 13 is a prime number. So it is written only 1 multiply 13 or 13 multiply 1. So these are the possible orders. Okay. So if this type of questions come, then I think you must solve it. Then come to question number 4. Question number 4, students. Construct a 2 by 2 matrix. Construct a 2 by 2 matrix A equal to Aij, 2 by 2 matrix, and where Aij is given. Aij equal to, the elements are in this form, I plus j whole square by 2. Okay, so it has 3 parts. So I am going to solve the first one. Construct a 2 by 2 matrix. So first we construct a matrix 2 by 2. So their elements, possible elements are A11, A12, A21, and A22. These are the 2 by 2 matrix and contains the element A11, A12, A21, A22. So A11, in the element A11, this element stands in first row and first column. So here I is equal to 1 and j is equal to 1. Similarly, for the element A12, I is equal to 1 and j is equal to 2. So very simple one to solve. So that implies A11 means, so here Aij, the general form of Aij is equal to what? I plus j whole square by 2. So you put the values here. 1 plus 1 whole square by 2. That is equal to 2 square by 2 equal to 4 by 2. 4 by 2, it is what? 2 now. Next one is A12, first row and second column. So I is equal to 1, j is equal to 2. So we put here 1 plus 2 square by 2, that is equal to 3 square, 9 by 2. A21, I is equal to 2 here, j is equal to 1, and its values is I plus j whole square by 2. So we write 2 plus 1 whole square by 2, that is equal to what? 2 plus 1, 3 square, 9 by 2. And A22, I is equal to 2 and j is equal to 2 here. So we write 2 plus 2 whole square by 2. So 4 square by 2, 16 by 2, 8. So tell me, what are the what is the matrix here? The matrix is here. We write what is the matrix now? It is 2, 9 by 2, 9 by 2, and 8. So the here is the construction of a 2 by 2 matrix if Aij given here, I plus j whole square by 2. So students, you solve question number 4 and 5. In question number 5, it is asking that construct a 3 by 4 matrix. So you solve here. First, you write the general form of a 3 by 4 matrix like A11. Question number 5, first part, I am solving here. Question number 5. We have to construct a 3 by 4 matrix. Construct a 3 by 4 matrix. Right, students? Just a minute. Just a minute, students. Construct a 3 by 4 matrix. So, A 3 by 4 is equal to matrix A is written as what? A11, A12, A13, and A14. Then A21, A22, A23, A24, A31, A32, A33, A34. So this is a 3 by a matrix of the order 3 by 4. Okay, and here what is given? Aij. Aij here half into minus 3i plus j modulus value of what? Modulus value, absolute value of minus 3i plus j. So you know that, students, the modulus value of every real number is always positive. Okay, so just a minute, you write here a11. So what you put here? Half I is equal to 1 here, j is equal to also 1 here. So you write uh, minus 3 into 1 plus 1. It is what is now? It is now half into minus 3 plus 1, minus 2 mod. It is 2 by 2, that means 1. Then a12 half into minus 3 into 1 plus 2. So it is half into minus 3 plus 2. It is minus 1 modulus value. So it is positive always. So it is 1 by 2. A13 half into minus 3 into 1 plus 3. So it is half into 0 modulus, yani 0. Right? Half into 0 equal to 0. A14, students. A14 half into minus 3 into 1 plus 4. Plus what? You write 4. So half into minus 3 plus, it is 1 mod. Half into 1, it is 1 by 2. Then come to, this is the first row and first column. First row and first row elements. There are 4 elements. So just solve it. Then come to the second row. A21. A21. It is what now? A21. Half into, put the value here, minus 3 into 2 plus 1. Minus 6 plus 1. It is what? Minus 5. Modulus of minus 5, 5 by 2. Then A22. Second row, second row. Half into, you put here in place of I 2 and j. What you put here in place of j? 2 also. Minus 6 plus 2. It is minus 4. 1 by 2 minus 4 mod. 4 by 2 it is 2. Then come to A23. You put here minus 3 into 2 plus 3. So it is half minus 6 plus 3. It is minus 3 modulus value of minus 3. It is 3 by 2, students. A24 half into minus 3 into 2 plus 3. So what to write here? Sorry, 4. It is not 3, 4. So it is half into minus 6 plus 2. It is minus 2. So it is 2 by 2 equal to 1. Right? So second row elements are also solved. Now come to third row elements. It is A31. A31, students. So half into minus 3 into 3 plus 1, because I is equal to 3 here and j is equal to 1. So minus 9 plus 1, minus 8. So half into minus 8 mod. It is 8 by 2, 4. Then A32 half into minus 3 into 3 plus 2. So that is equal to half into minus 9 plus 2. It is minus 7 modulus value. So 7 by 2. A33. Third row, third column. Half into minus 3 into what? 3 plus 3. It is minus 9 plus 3 minus 6. Minus 6 mod. It is 6 by 2 equal to 3. A34 half into minus 3 into 3 plus 4. So it is minus 9 plus 4 minus 5. Minus 5 modulus value is equal to 5 by 2. So students, this is the elements of the third row. So already we calculated first row element, second row element and third row element. So required matrix is what? Required matrix is what you write here? 1, 1 by 2, 0, 1 by 2, then 5 by 2, 2, 3 by 2, then 1, then third row elements are 4, 7 by 2, 3 and 5 by 2. Right students? So this is a matrix of order 3 by 4 which we already constructed. Okay. So second question you solve yourself. Right? Then equality matrix. Question number 7 I already discussed. So one of the question again I am going to discuss. Question number second, 6 second. Question number 6 second. Just a minute, students. Students, now come to question number 6. Question number 6, part 2. We have to find x, y and z. They are the equality matrices. X plus y 2, 5 plus z, x, y is equal to the matrix 6, 2 and 5, 8. And I told you that two matrices are said to be equal if they have the same order and each element of the first matrix is equal to corresponding element of the second matrix. Okay. So these are the, so clearly x plus y is equal to 6 and xy is equal to 8. I take x plus y is equal to 6 as equation 1 and xy is equal to 8 as equation 2. So put the value of x into from 1 x is equal to 6 minus y. Putting x is equal to 6 minus y into, we put x is equal to 6 minus y into in equation 2. What you get now? So now putting it is 6 minus y into y is equal to 8. So it is 6y minus y square minus 8 equal to 0. So it is only y square minus 6y plus 8 equal to 0. बच्चे आपको ऑलरेडी पता है 10th क्लास और 9th क्लास में हाउ टू 10th class how to solve a quadratic equation using splitting the middle term method. Okay, so using splitting the middle term method, it is minus 4y minus 2y plus 8 equal to 0. From the first two terms we take common y, it is y minus 4, and in the second it taking minus 2, it is y minus 4. Now it is y minus 4 into y minus 2. So that implies, students, y is equal to 4 and y is equal to 2. Right? So that implies x is equal to 6 minus y, it is 2, and here also x is equal to 6 minus 2, 4. So values of x and y are what? x2y4 or x4y2. These are the possible values of x and y from this equality of matrix we already calculated. Now come to, students, one of the most important question, question number 10. The number of all possible orders, possible matrix of order 3 by 3. The number of, I am writing the questions now, very important one, the number of all possible matrices of order 3 by 3 with each entry 0 or 1. It is saying that using the elements 0 or 1 only, we make a 3 by 3 matrix. Okay, so how many such matrices of order 3 by 3 are formed using 0 and or 1? So the formula is number of entries, total number of elements that means entries. कितना एंट्रीज है, कितना एलिमेंट्स लेते हैं, पावर द ऑर्डर. ऑर्डर क्या है? So how many entries are here? 0 or 2 means using only 2 entries. Total number of entries we write here. Entries. So how many elements we use here to make matrices 3 by 3 of the order 3 by 3? Using only the entries 0 or 1. So it is 2 and the order is what here? 3 by 3. So 2 power 9, it is equal to 512. Very, very important concept. So be careful and remember this one. Okay. So students, I think you must understood exercise 3.1 and just before the concept before exercise 3.1. Thank you, students.